Hi boys and girls, this is Mrs. Mouton and I'm bringing you a video about patterns, SOL 4.15. And remember that the three things that they want us to be able to do is to recognize, create, and extend patterns. There are two different types of patterns that we're going to mainly focus on. They are numerical, remember that has to do with numbers, and geometric patterns, which has to do with shapes. And don't just think about standard shapes. It could be little pictures of animals or anything like that is still considered to be in the geometric pattern category. They want you to understand patterns and functions can be represented in many ways and described using words, tables, graphs, and even symbols. You will understand patterns and identify them as either a repeating pattern, and we'll look at that later on in the video, one that continues to do the same thing over and over again, or a growing pattern, one that's getting larger. Now, when it comes to numbers and your in and out machines, know that the growing pattern doesn't necessarily mean that the numbers are getting larger. They could also be descending in nature, so they could be getting smaller. And you will describe the patterns that you see in words. Remember that patterns are going to be related to our next skill as well, because we're going to be looking at patterns on graphs later on. So this skill carries over to many different places. Even in your language arts, you're looking at patterns using your word study within words. So there are a lot of places where patterns cross over. In science, you'll be looking at patterns and using graphs to look at the information that you're covering. We look at weather patterns, so it's not just related to math. Remember that math is related to a lot of different areas as well. The first sample you have in your notebook is the one that appears below. It says the first 10 shapes in a pattern are shown below. Remember to always annotate your questions first so you'll understand what they're looking for. If the pattern continues in the same way, what will be the next two shapes in the pattern? Remember we said an easy way to look and see what's going on in the pattern is to describe it using letters. They're only looking for the next two shapes, so we don't have to go too far. Sometimes they'll ask us, in the next example we see, they'll ask us to go out farther than that, then we'll have to assign numbers to these as well. But since they're only looking for the next two shapes, it's easy enough to just know that we have to go two more spaces. But the big deal is that we're looking to see how this pattern continues, so we have to find what is actually repeating in the pattern. Or is it growing? When we assign letters to it, it makes it easier to see the pattern. So each time you have a new shape, even if it's in a different direction, it's considered a new shape. You give it a different letter. So this arrow pointing up would be A. Then the open circle would be B. The shaded circle C. This arrow gets a D because although it's still an arrow, it's pointing down now. So it's different. Next, this circle is a B again because it matches that one, and this shaded circle is a C. And we've come back to the beginning to our A again. So this would be the pattern that's repeating A, B, C, D, B, C before we come back to that original A again. So now they want to know the next two, so let's look and see what the pattern does. So it goes A, B, C, D. We look for the next two would be B and C, which are represented by the open white circle and the shaded circle. So those are the next two patterns, two objects or shapes in the pattern. Don't forget to use letters to make it simpler so that you can tell exactly what's going on in the pattern. That was a repeating pattern. This next pattern is a different type of pattern. This happens to be a, well, we'll find out in a minute. Again, we need to annotate. We're looking at the pattern. What will be the next shape? Most of the time we won't get questions like that because those are pretty simple. And then look at this one here. They want to know about the 15th shape. This is where our numbers are also going to come in and help us to determine the pattern, because we're going to have to count out 15. They don't want us to start here. They want us to start at the beginning and count out 15 to the 15th shape. So we give it its letters again to see it more easily. A, B, A, B, B, A, B, 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 A, B. Again, we see those B's. There's becoming more of them each time in between the A's. There's one here, then two, then three. So, in fact, this is a growing pattern because there are more added to this unit each time. So since we had 3, we know the very next one is going to be another B, because this time we will need to have, extending it out to 15, 4 of those ovals, since there were 3 last time, followed by a triangle, which is the 15th shape if you counted it out. Don't forget, when they ask you for a specific number, to use the numbers to help you extend the pattern. This question asks if it's a growing or repeating. We've already established that it is a growing because we're putting more ovals in each time. And the pattern is triangle oval, and we're adding an oval each time. It's growing by 1 oval. And next, you may see this format where you have a pattern on a number line. I think this is one of the most difficult ones you will see, because there are these spaces in between. So you have to really figure out what's the relationship between the numbers in order to figure out what the pattern is. The good thing with this one is that you have multiple choice, so you have some numbers to choose from. And all you have to do is plug those numbers in, try each one of them, and see which one actually works and has the pattern. Now, you can't see all the numbers that are on the number line, so your job is going to be to plug in each of these numbers at X, and then to also write the numbers that would come in between to see if they work. If you're going in this direction on the number line, numbers are getting larger. I apologize, went in the wrong direction. And in this direction, they're getting smaller. So again, they need to also do that same thing. If there were any numbers that were larger than 41, we know they wouldn't work, because X sits on this side with numbers that are smaller than 41. And we don't have any of those choices, but if we did, we would eliminate them. So we'll just randomly start trying them. 40 seems to be the easiest because we know how to count by ones. 40, 41, 42 doesn't work because here is 45. Then if we would go to in the other direction, descending 40, 39, 38, 33. We know that's not how we count by ones, so that can't be the correct answer. So we go on to try the next one. I just randomly chose 36, and again, looking at the numbers that are in between. 36, we would need to count 37, 38, 39, 40. Next would come 41. Then 42, 43, 44, 45 is not shown. Next would come 36 right here, but look at where 45 is. So it can't be in 2 different places, so obviously that one doesn't work, and we get rid of that one. Then we would try 37. And we would find that 37 also does not work, because again, if we list the numbers that are in between, we have to do that to show the pattern. 37 would go there, 38, 39, 40, 41. It looks like it works, but watch this. 42, 43, 44 are not listed, so the next line would belong to 45. And then we would have 46, 47, and we would have 48. So 45 can't appear in 2 places, so that one's not correct. The last one that we have to actually try is 39, but we still have to see if it works. 39, 40 is not written, but we can put it up here just so we can see it. 41, 42 is not written, but we can put it up there. 43 would be that next line there. Even though they don't have it written, we know that that's what would appear there. 44, and then 45. Again, your job is to fill in the missing numbers, even though they don't appear. So if that's 39, let's make sure it works going in this direction. We can't see 38, but it would be there. Then that would be 37. We wouldn't see 36. 35, we wouldn't see 34, and 33. So it does work in both directions, so that would be our answer. The next one is an example of a table. And you can have a table that goes in different directions. This one happens to go across. If you have one notebook, it's telling you that the cost of that notebook would be $3.50.
It's 6 o'clock.
I apologize. Then if you have two notebooks, it would show you that the cost of those two notebooks would be $7. And then it just continues. So you have to find out what's happening between the $3.50 for one and the $7 for two. Then the $10.50 for three. How is the cost of the notebooks increasing each time, and by what unit is it increasing each time? And we would have to go all the way to 6 notebooks. Now, we don't need to go back to 1 and count 6 of them because they've already done the math for us. We already have 7. All we have to do is add another, what, $3.50, because that's the cost of one notebook, and we want 6 notebooks. So, again, showing you that it increases each time by $3.50. And we're looking for the cost of 6 notebooks, so we take the $17.50 from the 5 notebooks and add $3.50, which is the cost of one more notebook to make it 6 notebooks. And when you add it, you get 21. There's your going back to show you that one notebook costs $3.50. $21 would be the cost of 6 notebooks. Now, they often do this. There's a jump. They didn't give you the information that you need, but you're going to have to add until you get to 10 notebooks. So we don't have to go back to the beginning because we already have $21 is what it costs for 6 notebooks. So add another $3.50 for 7 notebooks, gives you $24.50. Another $3.50, 8 notebooks will cost $28. Another $3.50, 9 notebooks will cost $31.50. And another $3.50, 10 notebooks will cost you $35. Be very careful when you're adding here. Some of you in class were forgetting 5 plus 5 equals 10. You write down the 0, but you regroup the 1. Make sure you are regrouping. 3 plus 1 is 4, and the 1 you regroup to makes that 5 there. So each time, I may not be showing it in here for the sake of time and moving through this quickly, but make sure you remember that you need to regroup. So the price of 10 notebooks is $35. Some of you in class also were bright enough to see if I know how much 5 notebooks cost, $17.50, then I can just add that $17.50 and another $17.50 because 5 plus 5 equals 10, and that will still give me $35. So there's more than one way to do it, but always show your work so that I can see where you may have made the mistake. Be careful with your computation because even if you know the pattern, you've got to add it correctly to get the correct answer. Here's one that tends to give you all a little bit of trouble, and this is called a function machine, better known as an in and out machine. And what it does, it describes it right here, is it uses a rule to change the numbers into other numbers. The pictures below show what happens when the numbers 4, 12, and 7 went into the machine. So a 4 went in, just like on our little Cyberchase website, and a 32 came out. 12 went in, 96 came out of the machine. 7 went in, 56 came out. They want you to find the rule and explain what's happening to these numbers. Remember, these are the easiest of the patterns because with a function machine, it will always use the same function or operation, which math ninjas, we know that there are 4 of them: addition, subtraction, multiplication, and division. And it will use the same number. So if you're adding whatever number, adding 1, which we know is not true because 4 plus 1 would be 5. But if we were adding 1, you would add 1 for each of these. So it's relatively easy, or easier than some of the other patterns because you use the same operation and the same number with each of them. Just make sure it actually works with each of them before you choose it. So we know that the number is getting larger, and math ninjas, you know there are only 2 operations that make a number larger, and that would be addition and multiplication. So we would multiply or add. So we're asking ourselves, 4 plus what number? Because addition is the easiest one to try. If we have 4, and we add what number to it, will we get 32. And you can use the inverse operation if you're good at subtraction. 32 minus 4, because it's a fact family, will give you the number that belongs here. And 32 minus 4 gives you 28. So we take that 28, 4 plus 28 gives you 32. Just use the inverse operation to find the answer. Now, if it works here, it also has to work with all of these. So we would have to do 12 plus 32 would have to give us 96. I'm sorry, 12 plus 28. I apologize. 12 plus 28, because we found our rule is plus 28, or at least we think we're trying it out. But 12 plus 28, in fact, does not. 12 plus 28 gives us 40. Remember, when you add, put your numbers vertically going down the page, especially when there's two-digit numbers. Line up your place value. 8 plus 2 is 10. Sorry, it's a little hard to manage this. Regroup your 1. 2 plus 1 is 3. Plus 1 more makes 4. So this one would be 40. It does not work because we want it to be 96, not 40. And if it doesn't work for one of them, then it doesn't work for all of them. It has to be applied to all of them. Same function or operation and same number. So we're going to rule out addition because it doesn't work, and we're going to try multiplication. So now we go back. 4 times what number will give us 32? Again, if you're good at the inverse operation, what the opposite of multiplication is division, then you can just take 32, divide it by what number will give you 4. And we find out that 32 divided by 8 equals 4. Or you can do 32 divided by 4, equals 8. Long day. So either one of them will give you it. Again, it's a fact family, so it works. Or 4 times 8, if you know your multiplication really well, is 32. If you don't know your multiplication, you would have to find another way to do it. Repeated addition. Of course, this only shows 4, but you would go on to have 8 4s, add them up, and you would come up with 32 as your answer. So far, that works for this first box, but remember, if it works for one, it has to work for all of them in order to be your answer. So we're going to try times 8 with each of these, or multiply by 8. 12 times 8, if you know your multiplication facts again, is in fact 96. So 2 out of the 3 it works for. Let's try the last one. 7 times 8 is 56, so it worked for all of them. So our rule is to multiply by 8. And then again, it gave you a question down here. What will come out of the machine if the number 9 goes in? So what we will basically be doing is putting a 9 in on this side and saying what would come out on this side. Remember, our function is multiplied by 8. So 9 times 8 is 72, because a function machine uses the same number and operation each time. And that is it, ladies and gentlemen. One more thing, though. Remember, we just showed that function machine, or the in and out machine. It could have, and I'm sorry for my little funny drawing, have very well appeared this way. In and out. Sorry, it doesn't want to do what I want it to do. In and out. And then we would have our 4 and our 32. So don't get used to seeing it one way, because it can appear in more than one way. And then whatever our other numbers are, if it was 8, because we're multiplying by 8, it would be 64. And then sometimes they'll ask you, if it's 7, what would it be there? So they can ask you to find the function. They can also ask you to find the number that would complete the function machine. Function machines use the same number and operation with each one. I hope you'll go and visit the Cyberchase site on PBS Kids, or the Rhino game where you're practicing patterns this evening, and come in ready for your quiz, ready to go tomorrow. I'll see you in class.